This is the world's highest railway, the Qinghai-Tabet Railway. The isolated Tibetan Plateau is located in China's southwest. Entering the Tibetan Plateau on land is a long and hard journey. Chinese railway engineers oversaw the construction of the 1,100-kilometer railroad, of which 550 kilometers, roughly half of its total length, passes over permafrost, which can exceed 1,500 meters in depth. It's rock-hard in winter, but in summer the surface melts and sinks. When winter returns, it freezes, expands, and rises again. Once the permafrost melts, the railroad may collapse.
Our guideline for building the Qinghai-Tabet Railway on permafrost is this: to cool the soil of the railway bed and to reduce the amount of heat going into the ground. This makes the permafrost stable and stops the railway from sinking in summer.
The first step in dealing with the temperature is building large-scale bridges, but the most important part is its base. In the summer, hot air rises and escapes from the cracks in the rock. This pipe is filled with liquid ammonia and acts like a freezer. The soil's temperature vaporizes the liquid ammonia in the base of the pipes. The vapor rises up the pipes and dissipates. After the ammonia gas condenses, it flows back to the base of the ventilation pipe.
How are the concrete towers and bridges inserted into the extremely unstable permafrost without causing it to melt? The first step is to drill the holes in cold and dry weather. The towers and bridges are placed 20 meters deep into the permafrost. Concrete is a key element of modern architecture. Hundreds of thousands of bridges and towers use special concrete, which is chilled to a temperature of 5 degrees Celsius. When the concrete hardens, its temperature is the same as the permafrost, and becomes a part of the permafrost itself.
At such a high altitude, engineering teams face a huge challenge. As the permafrost melts, the ceiling of the tunnel starts to collapse. The workers may be killed or trapped within. To prevent accidents from happening, engineers have installed air conditioners to keep the temperature in the tunnel constantly low. When the temperature falls below the freezing point, permafrost cannot solidify properly. Tunnel engineers can only keep the concrete's temperature constant. This means that huge furnaces must be transported to high-altitude construction sites.
But permafrost is not the mission's only deadly enemy. 2,000 medical staff are employed to fulfill the medical needs of the workers working on a railroad. Workers are allowed 1 week's time to adapt to the thin oxygen level there. Even so, they need to inhale oxygen from supply tanks. Mountain sickness, sometimes fatal, is something common at 144 hospitals, having set up over 500 wards, thus allowing doctors to control mountain sickness among the workers.
Moreover, passengers on the train may also get mountain sickness due to the lack of oxygen. For this reason, the trains are manned by medical staff, and the air conditioning system directly emits oxygen into the train compartments. Also, the sliding doors have rubber fittings to avoid air escaping, and the double-pane windows are made of reinforced glass, and it can block UV rays.
The Qinghai-Tabet Railway had witnesses of breakthroughs in China's engineering technology. China has achieved a 50-year-old dream of connecting the isolated southwestern areas with the rest of the country.